Hello everyone, I'm January Rabino and today I will discuss on how to assign the end of it Hartenberg or DH frames in a cylindrical manipulator. So let's start. We need to determine the different frames of our manipulator because we cannot distinguish the exact position of the joints and the end effector if we don't know the frames. Another crucial point is that creating a program for the manipulator would be impossible without this information. That's why assigned H frames is essential for this program. When designing a manipulator like cylindrical, we should look at it as a 3D objects. That's why we have three axes, the X, Y, and Z axis. Next is to assign the link lengths and joint variables, which is denoted as the theta n for revolute joint and d sub n is for prismatic joint. For better understanding, we will assign the three axes to our right hand. The z-axis is our thumb, while our four remaining fingers are the x-axis, and lastly, the face of our palm is the y-axis. Now that we know the procedures, we should proceed to the solution. This is the cylindrical manipulator. So link lengths which we can use the variable a sub n. We're gonna start from the base zero or frame zero up to the center of the frame one and labeled as a sub one. This one. Next is from the center of frame one to the next, which is frame two, and it is labeled as a sub two. This one. Next, and lastly, is from the center of frame 2 to the frame of the end effector, and it will be labeled as A sub 3, this one. Now that the link lengths are done, next is joint variables. We will start from the base up to the last joint. As I discussed earlier, the joint variable for the revolute joint is theta, and in prismatic is D. Since the first joint is revolute joint, we can put here is theta sub 1. This one. This is the theta sub 1. See, next is prismatic joint. So I will put it as D sub 2. This one is D sub 2. And lastly, a prismatic again. So we can simply put D sub 3 here. This is the D sub 3. For the next is assigning frames to cylindrical manipulator. We will start to appoint the frames using the DH frame rules. And the first frame, the rule number 1 is the z-axis must be the axis of rotation for volute or twisting or the direction of translation for prismatic joint. In the first, the volute joint, the direction of the arrow is pointing upward and it will be designated as z sub 0. This one, pointing upward is z sub 0. Second frame, the direction of the arrow in the second prismatic joint is pointing upward and it will be denoted as Z sub 1. This one, pointing upward is the Z sub 1. Third frame, the arrow in this prismatic joint is pointing rightward and it will be denoted as Z sub 2. This one, pointing rightward, the Z sub 2. Last is the end effector, the tool frame also known as the end effector, has an arrow that points rightward and is labeled as Z sub 3, this one. So here are the complete frames that adhere to the rule number 1. Then let's proceed applying rule 2 to the frames. Rule 2 states that the x-axis must be perpendicular both to its own z-axis and the z-axis of the frame before it. In the first frame, in the first revolute joint, the direction of the arrow is pointing to the rightward, and it will be labeled as x sub 0. This one. This one is the x sub 0. While in the second frame, the direction is of the direction is also heading to the rightward for this second prismatic joint, which is going to be known as x sub 1. This one pointing rightward is the x sub 1. In the third frame, the arrow is in this prismatic joint is pointing to the frontward, and it will be known as x sub 2. This one pointing front is the x sub 2, and the end effector to the last has an arrow pointing in the same frontward direction, and it will be denoted as x sub 3. This one is the end effector, and it's pointing front. So if we're going to extend for rule number 3, it states that each x-axis must intersect the z-axis of the frame before it. The rules for complying rule 3 is we have to rotate the x-axis until it hits the other, or translate the axis until it hits the other. So if we're going to extend z sub 0 upward, we can see that it will intersect with x sub 1. Therefore, it complies with rule number 3. This one, if we extend this z sub 0 upward, and it will intersect with z sub 1 and comply with rule number 3. Next, we can see that if we extend z sub 1 upward, it intersect with x sub 2 as a result. The rule number, and it complies with rule number 3. And finally, extending z sub 2 downward reveals that it intersects with x sub 3, thus it complies with rule number 3. This one, z sub 2 and it we extend if we extend it downward, it intersect with x sub 3. Applying Applying for rule 4 to the frames. Rule 4 states that all frames must follow the right-hand rule. In the first bullet joint, the direction of the arrow is pointing backward, and it will be named as y sub 0. This one is pointing backward, the y sub 0. A similar arrow direction is present at the second prismatic joint, which will be referred to as y sub 1. This one is the y sub 1 pointing also in back. Next is the arrow direction in this prismatic joint. This prismatic joint is pointing downward, and it will be designated as y sub 2. This one pointing downward is the y sub 2. The end effector will be labeled as y sub 3, and will have an arrow also pointing front direction. We can say that all frames comply to the DH frame rule.